Hi, this is Sleeper, and we are continuing with our Bug Bounty Hunter job role path with our next module, Introduction to Web Applications. So we'll start with the module summary. So this module is your first step into web application pen testing. It teaches important aspects of web applications which will help you understand how web application pen testing works. This module will cover the following topics: Intro to Web Applications, Web application architectures, front end versus back end. So the front end components, HTML, CSS, JavaScript, and the front end vulnerabilities, data exposure, HTML injection, XSS cross-site scripting, and CSRF cross-site request forgery, and the back-end components, back-end servers, web servers, databases, development frameworks and APIs, back-end vulnerabilities, public vulnerabilities, common web vulnerabilities. The following are also some of the covered topics. What is a web application? What are the common web application architectures? What are the most common web servers, and what are the advantages of each? What types of databases are there, and where is each one used? Common web application development frameworks. What are APIs and how are they used? Public web application vulnerabilities, and the introduction to the OWASP Top 10 for web applications. So let's go ahead and get started. Starting with an introduction. Web applications are interactive applications that run on web browsers. Web applications usually adopt a client-server architecture to run and handle interactions. They typically have front-end components, for example, the website interface or what the user sees, that run on the client-side browser, and other back-end components, web application source code, that run on the server side, the back-end server/databases. This allows organizations to host powerful applications with near-complete real-time control over their design and functionality while being accessible worldwide. Some examples of typical web applications include online email services like Gmail, online realtors like Amazon, and online word processors like Google Docs. Web applications are not exclusive to giant providers like Google or Microsoft, but can be developed by any web developer and hosted online in any of the common hosting services to be used by anyone on the internet. This is why today we have millions of web applications all over the internet, with billions of users interacting with them every day. Web applications versus websites. In the past, we interacted with websites that are static and cannot be changed in real time. This means that traditional websites were statically created to represent specific information, and this information would not change with our interaction. To change the website's content, the corresponding page has to be edited by the developers manually. These types of static pages do not contain functions and therefore do not produce real-time changes. That type of website is also known as Web 1.0. So website static pages, same for everyone. With a web app, we have dynamic pages. It's interactive. We have a different view for each user, and it is functional. So on the other hand, most websites run web applications or Web 2.0, presenting dynamic content based on user interaction. Another significant difference is that web applications are fully functional and can perform various functionalities for the end user, while websites lack this type of functionality. Other key differences between traditional websites and web applications include being modular, running on any display size, and running on any platform without being optimized. Web applications versus native operating system applications. Unlike native operating system, native OS applications, web applications are platform independent and can run in a browser on any operating system. These web applications do not have to be installed on a user's system because these web applications and their functionality are executed remotely on the remote server and hence do not consume any space on the end user's hard drive. Another advantage of web applications over native OS applications is version unity. All users accessing a web application use the same version and the same web application, which can be continuously updated and modified without pushing updates to each user. Web applications can update in a single location, web server, without developing different builds for each platform, which dramatically reduces maintenance and support costs, removing the need to communicate changes to all users individually. On the other hand, native OS applications have certain advantages over web applications, mainly their operation speed and the ability to utilize native operating system libraries and local hardware. As native applications are built to utilize native OS libraries, they are much faster to load and interact with. Furthermore, native applications are usually more capable than web applications, as they have a deeper integration to the operating system and are not limited to the browser's capabilities only. More recently, however, hybrid and progressive web applications are becoming more common. They utilize modern frameworks to run web applications using native OS capabilities and resources, making them faster than regular web applications and more capable. Web application distribution. There are many open source web applications used by organizations worldwide that can be customized to meet each organization's needs. Some common open source web applications include WordPress, OpenCart, Joomla. There are also proprietary closed source web applications, which are usually developed by a certain organization and then sold to another organization or used by organizations through a subscription plan model. Some common closed source web applications include Wix, Shopify, and .NET Nuke. Security risks of web applications. Web application attacks are prevalent and present. One second here. Web application attacks are prevalent and present a challenge for most organizations with a web presence, regardless of their size. After all, they are usually accessible from any country by everyone with an internet connection and a web browser and usually offer a vast attack surface. There are many automated tools for scanning and attacking web applications that, in the wrong hands, can cause significant damage. As web applications become more complicated and advanced, so does the possibility of critical vulnerabilities being incorporated into their design. A successful web application attack can lead to significant losses and massive business interruptions. Since web applications are run on servers that may host other sensitive information and are often also linked to databases containing sensitive user or corporate data, all of this data could be compromised if a website is successfully attacked. This is why it is critical for any business that utilizes web applications to properly test these applications for vulnerabilities and patch them promptly, while testing that the patch fixes the flaw and does not inadvertently introduce any new flaws. Web application penetration testing is an increasingly critical skill to learn. Any organization looking to secure their internet-facing and internal web applications should undergo frequent web application tests and implement secure coding practices at every development lifecycle stage. To properly pen test web applications, we need to understand how they work, how they are developed, and what kind of risk lies at each layer and component of the application depending on the technologies in use. Excuse me. We will also come across various web applications that are designed and configured differently. One of the most current and widely used methods for testing web applications is the OWASP Web Security Testing Guide. One of the most common procedures is to start by reviewing a web application's front-end components, such as HTML, CSS, and JavaScript, also known as the front-end trinity, and attempt to find vulnerabilities such as sensitive data exposure and cross-site scripting, XSS. Once all front-end components are thoroughly tested, we would typically review the web application's core functionality and the interaction between the browser and the web server to enumerate the technologies the web server uses and look for exploitable flaws. We typically assess web applications from both an unauthenticated and authenticated perspective, if the application has login functionality, to maximize coverage and review every possible attack scenario. Attacking web applications. In this day and age, most every company, no matter the size, has one or more web applications within their external perimeter. These applications can be everything from simple static websites to blogs powered by content management systems, CMS, such as WordPress, to complicated applications with sign-up/login functionality, supporting various user roles from basic users to super admins. Nowadays, it is not very common to find an externally facing host directly exploitable via a known public exploit, such as a vulnerable service or Windows Remote Code Execution Vulnerability, RCE, though it does happen. Web applications provide a vast attack surface, and their dynamic nature means that they are constantly changing and overlooked. A relatively simple code change may introduce a catastrophic vulnerability or a series of vulnerabilities that can be chained together to gain access to sensitive data or remote code execution on the web server or other hosts in the environment, such as database servers. It is not uncommon to find flaws that can lead directly to code execution, such as a file upload form that allows for the upload of malicious code, or a file inclusion vulnerability that can be leveraged to obtain remote code execution. A well-known vulnerability that is still quite prevalent in various types of web applications is SQL injection. This type of vulnerability arises from the unsafe handling of user-supplied input. It can result in access to sensitive data, reading or writing files on the database server, or even remote code execution. We often find SQL injection vulnerabilities on web applications that use Active Directory for authentication. While we can usually not leverage this to extract passwords, since Active Directory administers them, we can often pull most or all Active Directory user email addresses, which are often the same as their usernames. This data can then be used to perform a password spraying attack against web portals that use Active Directory for authentication, such as VPN or Microsoft Outlook Web Access / Microsoft O365. A successful password spray can often result in access to sensitive data, such as email, or even a foothold directly into the corporate network environment. This example shows the damage that can arise from a single web application vulnerability. especially when chained, to extract data from one application that can be used to attack other portions of a company's external infrastructure. A well-rounded InfoSec professional should have a deep understanding of web applications and be as comfortable attacking web applications as performing network penetration testing and Active Directory attacks. A penetration tester with a strong foundation in web applications can often set themselves apart from their peers and find flaws that others may overlook. A few more real-world examples of web application attacks and the impact are as follows. So our flaw, SQL injection, real-world scenario, obtaining Active Directory usernames and performing a password spraying attack against a VPN or email portal. We have file inclusion, reading source code to find a hidden page or directory, which exposes additional functionality that can be used to gain remote code execution. Unrestricted file upload, a web application that allows a user to upload a profile picture that allows any type of file to be uploaded, not just images. This can be leveraged to gain full control of the web application server by uploading malicious code. Insecure direct object referencing, IDOR, when combined with a flaw such as broken access control, this can often be used to access another user's files or functionality. An example would be editing your user profile browser to a page such as /user/701/edit profile. If we can change the 701 to 702, we may edit another user's profile. And broken access control. Another example is an application that allows a user to register a new account. If the account registration functionality is designed poorly, a user may perform privilege escalation when registering. Consider the post request when registering a new user, which submits the data username equals bjones and password equals welcome1 and email equals bjones@inlinefreight.local and role ID equals 3. What if we can manipulate the role ID parameter and change it to 0 or 1? We have seen real-world applications where this was the case, and it was possible to quickly register an admin user and access many unintended features of the web application. Start becoming familiar with common web application attacks and their implications. Don't worry if any of these terms sound foreign at this point. They will become clearer as you progress and apply an iterative approach to learning. It is imperative to study web applications in depth and become familiar with how they work in many different application stacks. We will see web application attacks repeatedly during our Academy journey on the main Hack the Box platform and in real-life assessments. Let's dive in and learn the structure/function of web applications to become better informed attackers, set us apart from our peers, and find flaws that others may overlook. Web application layout. No two web applications are identical. Businesses create web applications for a multitude of uses and audiences. Web applications are designed and programmed differently, and back-end infrastructure can be set up in many different ways. It is important to understand the various ways web applications can run behind the scenes, the structure of an application, its components, and how they can be set up within a company's infrastructure. Web application layouts consist of many different layers that can be summarized with the following 3 main categories. Web application infrastructure describes the structure of required components such as the database needed for the web application to function as intended. Since the web application can be set up to run on a separate server, it is essential to know which database server it needs to access. Web application components. The components that make up a web application represent all the components that the web application interacts with. These are divided into the following three areas: the UI/UX, client, and server components. And the web application architecture. Architecture comprises all the relationships between the various web application components. Web application infrastructure. Web applications can use many different infrastructure setups. These are also called models. The most common ones can be grouped into the following four types: client server, one server, many servers, one database, and many servers, many databases. Client server. Web applications often adopt the client server model. A server hosts the web application in a client server model and distributes it to any clients trying to access it. In this model, web applications have two types of components: those in the front end, which are usually interpreted and executed on the client-side browser, and components in the back end, usually compiled, interpreted, and executed by the hosting server. When a client visits the web application's URL, the web address, for example, acme.local, the server uses the main web application interface, the UI. Once the user clicks on a button or requests a specific function, the browser sends an HTTP web request to the server, which interprets this request and performs the necessary tasks to complete the request. For example, logging the user in, adding an item to the shopping cart, browsing to another page, etc. Once the server has the required data, it sends the result back to the client's browser, displaying the results in a human-readable way. This website we are currently interacting with is also a web application, developed and hosted by HackTheBox, the web server, and we access it and interact with it using our web browser client. However, even though most web applications utilize a client-server front-back-end architecture, there are many design implementations. We have the one server. In this architecture, the entire web application, or even several web applications and their components, including the database, are hosted on a single server. Though this design is straightforward and easy to implement, it is also the riskiest design. If any web application hosted on this server is compromised in this architecture, then all the web application's data will be compromised. This design represents an all eggs in one basket approach, since if any of the hosted web applications are vulnerable, the entire web server becomes vulnerable. Furthermore, if the web server goes down for any reason, all hosted web applications become entirely inaccessible until the issue is resolved. Many servers, one database. This model separates the database onto its own database server and allows the web application's hosting server to access the database server to store and retrieve data. It can be seen as many servers to one database and one server to one database, as long as the database is separated on its own database server. This model can allow several web applications to access a single database to have access to the same data without syncing the data between them. The web applications can be replications of one main application, for example, primary or backup, or they can be separate web applications that share common data. This model's main advantage from a security point of view is segmentation, where each of the main components of a web application is located and hosted separately. In case one web server is compromised, other web servers are not directly affected. Similarly, if the database is compromised, for example through a SQL injection vulnerability, the web application itself is not directly affected. There are still access control measures that need to be implemented after asset segmentation, such as limiting web application access to only data needed to function as intended. Many servers, many databases. This model builds upon the many servers, one database model. However, within the database server, each web application's data is hosted in a separate database. The web application can only access private data and only common data that is shared across web applications. It is also possible to host each web application's database on its own separate database server. This design is also widely used for redundancy purposes, so if any web server or database goes offline, a backup will run in its place to reduce downtime as much as possible. Although this may be more difficult to implement and may require tools like load balancers to function appropriately, this architecture is one of the best choices in terms of security due to its proper access control measures and proper asset segmentation. Aside from these models, there are other web application models available, such as serverless web applications or web applications that utilize microservices. Web application components. Each web application can have a different number of components. Nevertheless, all the components of the models mentioned previously can be broken down to 1. A client, 2. Server, a web application logic, database, 3. Services or microservices, third-party integrations, web application integrations, and 4. Functions, serverless. Web application architecture. The components of a web application are divided into three different layers, aka the three-tier architecture. We have the presentation layer, consists of UI processes, process components that enable communication with the application and the system. These can be accessed by the client via the web browser and are returned in the form of HTML, JavaScript, and CSS. The application layer. This layer ensures that all client requests, web requests, are correctly processed. Various criteria are checked, such as authorization, privilege, and data passed onto the client. And the data layer. The data layer works closely with the application layer to determine exactly where the required data is stored and can be accessed. An example of a web application architecture could look something like this. Furthermore, some web servers can run operating system calls and programs like IIS, ISAPI, or PHP CGI. Microservices. We can think of microservices as independent components of the web application, which in most cases are programmed for one task only. For example, for an online store, we can decompose core tasks into the following components: registration, search, payments, ratings, reviews. These components communicate with the client and with each other. The communication between these microservices is stateless, which means that the request and response are independent. This is because the stored data is stored separately from the respective microservices. The use of microservices is considered service-oriented architecture, SOA, built as a collection of different automated functions focused on a single business goal. Nevertheless, these microservices depend on each other. Another essential and efficient microservice component is that they can be written in different program languages and still interact. Microservices benefit from easier scaling and faster development of applications, which encourages innovation and speeds up market delivery of new features. Some benefits of microservices include agility, flexible scaling, easy deployment, reusable code, and resilience. This AWS white paper provides an excellent overview of microservice implementation. Serverless. Cloud providers such as AWS, GCP, Azure, among others, offer serverless architectures. These platforms provide application frameworks to build such web applications without having to worry about the servers themselves. These web applications then run in stateless computing containers, Docker, for example. This type of architecture gives a company the flexibility to build and deploy applications and services without having to manage infrastructure. All server management is done by the cloud provider, which gets rid of the need to provision, scale, and maintain servers needed to run applications and databases. You can read more about serverless computing and its various use cases here. Architecture security. Understanding the general architecture of web applications and each web application's specific design is important when performing a penetration test on any web application. In many cases, an individual web application's vulnerability may not necessarily be caused by a programming error, but by a design error in its architecture. For example, an individual web application may have all of its core functionality secure implemented. However, due to a lack of proper access control measures in its design, for example, use of role-based access control, users may be able to access some admin features that are not intended to be directly accessible to them, or even access other users' private information without having the privileges to do so. To fix this type of issue, a significant design change would need to be implemented, which would likely be both costly and time-consuming. Another example would be if we cannot find the database after exploiting a vulnerability and gaining control over the back-end server, which may mean that the database is hosted on a separate server. We may only find part of the database data, which may mean that there are several databases in use. This is why security must be considered at each phase of web application development, and penetration tests must be carried throughout the web application development lifecycle. Front end versus back end. We may have heard the terms front end and back end web development, or the term full stack web development, which refers to both front and back end web development. These terms are becoming synonymous with web application development, as they comprise the majority of the web development cycle. However, these terms are very different from each other, as each refers to one side of the application, and each function and communicate in different areas. The front end, The front end of a web application contains the user's components directly through their web browser, the client side. These components make up the source code of the web page we view when visiting a web application and usually include HTML, CSS, and JavaScript, which is then interpreted in real time by our browsers. This includes everything that the user sees and interacts with, like the page's main elements, such as the title and text HTML, the design and animation of all the elements, CSS, and what function each part of the page performs, JavaScript. In modern web applications, front-end components should adapt to any screen size and work within any browser on any device. This contrasts with back-end components, which are usually written for a specific platform or operating system. If the front end of a web application is not well optimized, it may make the entire web application slow and unresponsive. In this case, some users may think that the hosting server or their internet is slow, while the issue lies entirely on the client side at the user's browser. This is why the front end of a web application must be optimized for most platforms, devices, including mobile, and screen sizes. Aside from front-end code development, the following are some of the other tasks related to front-end web application development: visual concept web design, user interface design, and user experience design. There are many sites available to us to practice front-end coding. One example is this one. Here we can play around with the editor, typing and formatting text and seeing the resulting HTML, CSS, and JavaScript being generated for us. Copy and paste this very simple example into the right-hand side of the editor. Okay, let's do that. So we opened it in a new tab. We agree. On the right-hand side, let's just paste this. It said right-hand side, so enter. Or is it the left-hand side? Okay. So this is the HTML code. This is the HTML section. Okay. Welcome to the Hack the Box. This is some italic text. This is some blue text. What is this? Interesting. Okay. Anywho, let's go back. Okay. Watch the simple HTML code render on the left. Play around with the formatting, headers, colors, etc., and watch the code change. So let's go back. So you can mess with this if you want. The styles down here, we can change that. Back end. The back end of a web application drives all of the core web application functionalities, all of which is executed at the back end server, which processes everything required for the web application to run correctly. It is the part we may never see or directly interact with, but a website is just a collection of static web pages without a backend. There are 4 main backend components for web applications. Backend servers, the hardware and operating system that hosts all other components and are usually run on operating systems like Linux, Windows, or using containers. Web servers. Servers handle HTTP requests and connections. Some examples are Apache, Nginx, and IIS. Databases. Databases are DBs, store and retrieve the web application data. Some examples of relational databases are MySQL, MS SQL, Oracle, PostgreSQL, while examples of non-relational databases include NoSQL and MongoDB. Development frameworks. are used to develop the core web application. Some well-known frameworks include Laravel, PHP, ASP.NET, and C#, Spring, Java, Django, and Python, and Express, Node.js, JavaScript. It is also possible to host each component of the backend on its own isolated server or in isolated containers by utilizing services such as Docker to maintain logical separation and mitigate the impact of vulnerabilities. Different components of the web application, such as the database, can be installed in one Docker container, while the main application is installed in another, thereby isolating each part from potential vulnerabilities that may affect the other container or containers. It is also possible to separate each into its dedicated server, which can be more resource intensive and time consuming to maintain. Still, it depends on the business case and design/functionality of the web application in question. Some of the main jobs performed by backend components include develop the main logic and services of the backend of the web application, develop the main code and functionalities of the web application, develop and maintain the backend database, develop and implement libraries to be used by the web application, implement technical business needs for the web application, implement the main APIs for front-end component communications, and integrate remote servers and cloud services into the web application. Securing front/backend. Even though in most cases we will not have access to the backend code to analyze the individual functions and the structure of the code, it does not make the application invulnerable. It could still be exploited by various injection attacks. For example, suppose we have a search function in a web application that mistakenly does not process our search queries correctly. In that case, we could use specified techniques to manipulate the queries in such a way that we gain unauthorized access to specific database data, SQL injections, or even operating system commands via the web application, also known as command injections. We will later discuss how to secure each component used on the front and back ends. When we have full access to the source code of front-end components, we can perform a code review to find vulnerabilities, which is part of what is referred to as white box pen testing. On the other hand, back-end components source code is stored on the back-end server, so we do not have access to it by default, which forces us to only perform what is known as black box pen testing. However, as we will see, some web applications are open source, meaning we will likely have access to their source code. Furthermore, some vulnerabilities, such as local file inclusion, could allow us to obtain the source code from the backend server. With the source code in hand, we then can perform a code review on the backend components to further understand how the application works, potentially find sensitive data in the source code, such as passwords, and even find vulnerabilities that would be difficult or impossible to find without access to the source code. The top 20 most common mistakes web developers make that are essential for us as penetration testers are permitting invalid data to enter the database, focusing on the system as a whole, establishing personally developed security methods, treating security as your last step, developing plain text password storage, creating weak passwords, storing unencrypted data on the database, depending excessively on the client side, being too optimistic, permitting variables via the URL path name, trusting third-party code, hard-coding backdoor accounts, unverified SQL injections, remote file inclusions, insecure data handling, failing to encrypt data properly, not using a secure cryptographic system, ignoring layer 8, review user actions, and web application firewall misconfigurations. These mistakes lead to the OWASP Top 10 vulnerabilities for web applications, which will be discussed in other modules. The OWASP Top 10 here: broken access control, cryptographic failures, injection, insecure design, security misconfiguration, vulnerable and outdated components, identification and authentication failures, software and data integrity failures, security logging and monitoring failures, server-side request forgery is the last. It is important to begin to familiarize ourselves with these flaws and vulnerabilities, as they form the basis for many of the issues we cover in future web and even non-web related modules. As penetration testers, we must have the ability to competently identify, exploit, and explain these vulnerabilities for our clients. Let's see where we're at. HTML and just the time here, if I have one. 47 minutes. Okay. Let's go ahead and end there. That's been the introduction to web applications, the first few sections. In the second section here, in the second part 2, we'll run through the front-end components, front-end vulnerabilities, the back-end components, and the back-end vulnerabilities. So once again, my name is Sleeper, and that's a wrap. Until next time.